Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why some beliefs just stick with us no matter what, even when new information comes along? Well, this new study might have a clue. Today, we're diving into a fascinating idea called attractor accommodation. This research explores why certain deeply held beliefs can be so hard to change. Think about them like mental traps. In psychology, especially when we talk about conditions like delusional disorder, what we often see are these very fixed beliefs that are kind of isolated from the rest of a person's thinking. It's like a small part of the brain gets stuck on one idea and it remains that way even when other parts of the brain are working just fine. Scientists have tried to explain this using concepts like the brain giving too much importance to certain information or not updating beliefs properly. But what they weren't quite sure about is how a belief gets so stuck that it stays fixed even after whatever started it has gone away. Imagine a door that gets stuck shut and you can't open it anymore, even if the reason it jammed is no longer there. This is the puzzle the researchers set out to explore. Their big idea is called attractor accommodation. Think of your brain as a network of interconnected nodes, like a big web. When a belief is strongly held, maybe it influences all the connections around it. This idea suggests that over time, the brain literally rewires itself to make that strong belief a more stable and comfortable place to be. It's like the belief creates a little valley in the brain's landscape of thoughts. And that valley becomes so deep that it's hard to climb out of. So how did they test this idea? They used a computer model a bit like a simplified brain called a Hopfield network. Imagine this network storing different patterns of information. They then simulated a strong belief by clamping one part of the network to a specific state. While this part was clamped, they allowed the connections in the network to change a process they called plasticity. This is like the brain learning and adapting. They let this plasticity happen for a while. Then they did something really crucial. They released the clamp, they took away the forced belief and let the network settle on its own to see if the belief would disappear. This is like removing the initial stressor that might have caused the belief in the first place. They wanted to see if the network would just go back to its normal healthy state, or if it would stay stuck in the belief. And here are some of the really cool things they found. First, they discovered a critical point. There seems to be a certain amount of this brain rewiring plasticity needed for the belief to become permanently stuck. If the plasticity was too low, the belief would go away when they released the clamp. But if it crossed a certain threshold, even a small one, a specific amount of plasticity, then the belief would stay locked in place. This threshold effect was quite dramatic. It wasn't a gradual change, it was more like a switch flipping. Below this critical point of plasticity, the belief disappears completely when the clamp is removed. Above it, it stays stuck 100% of the time. This is a big deal because it suggests there might be a specific tipping point in how the brain changes that makes beliefs treatment-resistant. To really prove their point, they did a clever experiment. They took the network that had become stuck in a belief and they essentially swapped out the brain's wiring. They compared what happened when the network was settled with the original wiring versus the new or plastic wiring that had developed during the clamped period. When they used the original wiring, the belief disappeared and the network recovered, but when they used the plastic wiring, the belief stayed stuck no matter what. This clearly showed that the persistence of the belief wasn't just about the state of the belief itself, but about the actual physical changes in the network connections. The wiring had been reorganized to support the belief. They also found that the deeper the belief became locked in, the more resistant it was to any attempts to change it. This resistance was related to how much plasticity had occurred and for how long. They described this as a multiplication effect of plasticity rate and duration. So a little bit of plasticity for a long time could have the same effect as a lot of plasticity for a short time. This makes sense because it suggests that sustained exposure to a fixed idea, even if it's not super intense, can lead to deep structural changes. Now, it's important to remember what this model doesn't do. It doesn't tell us why someone forms a belief in the first place. It focuses on what happens after a belief is already fixed. It also simplifies complex brain processes into these network connections. Real beliefs are rich with emotions and personal meaning, and this model is a simplified representation. It is a prototype to help us understand a mechanism, not to explain every detail of a real delusion. So what does this all mean? This idea of attractor accommodation offers a new way to think about why some beliefs become so persistent. It suggests that it is not just about faulty thinking processes, but about the fundamental way our brains learn and adapt. When a belief is held strongly for long enough, the brain can literally change its own structure to make that belief more stable. This can create a kind of mental trap that is hard to escape. This is particularly relevant for conditions like delusional disorder, where these fixed beliefs are central. It might explain why treatment can be so difficult because the problem isn't just the belief itself, but the underlying rewiring of the brain that supports it. If the brain has reconfigured itself to make a belief an attractor state, it becomes much harder to dislodge. This research is like building a Lego model of a brain process. It helps us see how the pieces fit together and what mechanisms might be at play. The fact that the weights, the connections between nodes, are what truly hold the belief in place is a key insight. It takes the focus from just the content of the belief to the physical structure of the brain that supports it. Imagine a beautiful house that gets a little bit of damage in one room. The rest of the house is still perfectly functional. This is kind of like delusional disorder as described in the paper. The belief is like a damaged room, but the other parts of the cognitive house are still in pretty good shape. This helps explain why people with delusional disorder often maintain much of their daily functioning. The rewiring is focal, it doesn't necessarily break the whole system. The researchers also found that this focal nature of the adaptation remained consistent even when they scaled up their model. The lodged belief was like a single stubborn point that didn't spread chaos everywhere. This reinforced the idea that the disruption is specific and encapsulated, not a global breakdown. One of the most compelling findings was this sharp threshold. It suggests that there isn't just a little bit of resistance to change, it is either not stuck at all or it is incredibly stuck. This kind of tipping point behavior is seen in other complex systems, and seeing it here in a model of belief persistence is really thought-provoking. It means that once you hit a certain level of brain rewiring, it becomes much harder to reverse. The idea that the strength and duration of this brain rewiring multiply to create stability is also significant. It means that even a mild but very long-lasting fixed idea could lead to the same kind of deep ingrained belief as a very intense but shorter period of fixation. This has implications for understanding how chronic beliefs develop over time. So what does this mean for us? For people working in mental health, it provides a potential mechanism to explain treatment resistance. It means that interventions might need to consider not just challenging the belief itself, but also the underlying structural changes in the brain. For individuals, it might offer a framework for understanding why our own deeply held beliefs can be so hard to shake for better or worse. It highlights that our brains are constantly adapting, and sometimes that adaptation can lead us into mental traps. It is always important to look at the limitations, though. As the authors mentioned, this is a computational model. It simplifies a very complex biological and psychological phenomenon. It doesn't capture the rich emotional and personal aspects of real delusions. Also, the exact biological mechanisms of plasticity in the brain are way more complicated than what this model represents. But this kind of research is super valuable because it gives us concrete hypotheses to test. Future work could explore how different types of brain plasticity might contribute to this effect. Maybe interventions could be designed to specifically target the rewiring process. Could we find ways to encourage the brain to unlearn these deeply ingrained patterns? This research is a great example of how computational models help us explore complex questions in psychology. By building simplified systems that mimic brain processes, we can test theories and generate new insights into challenging conditions. It is a step towards understanding the stubbornness of our beliefs and paving the way for potentially more effective treatment. What do you think about Attractor accommodation? Let me know your thoughts in the comments below. And if you found this breakdown helpful, please give it a thumbs up and subscribe to RUBIN'S Mind Lab for more science explained simply. We'll see you next time.